Welcome, friends. In this session, we are going to discuss about capacity planning, and particular in this session, we are taking the systematic approach for capacity planning. That means you are going to learn what is the systematic approach or what are the various steps in the capacity planning. We are also going to learn various tools for capacity planning, just like simulation tool, waiting line models, then decision tree. All these we are going to discuss in this session. And the most important point which we will cover in this session is how to estimate or how to determine the capacity. If you know certain inputs, then how you will measure the capacity. So we have taken one example and we have tried to explain with the help of that example. When we are going to discuss certain aspects of capacity planning, a very important point of discussion is between the capacity and the location decision. This point, if you just remember our session on the location decision, we have tried to explain there that if your capacity is going more and more and you are not able to accommodate that capacity within your limits, you go for the alternative plant location. So one has to see that how our capacity will match with the location decision. A firm that is expanding eventually must append in new facilities and find suitable location for them, whereas a firm that is downsizing often must identify which location to eliminate. That means if a firm has two locations and they are going to get the more market share, they should go for more number of locations. But if a firm has a 4 location but they are not having the demand even for 2 locations, they should downsize their location. They should give away 1 or 2 location so that they can minimize the cost. There is one example of General Motor. They slice back its capacity by shutting down several factories to stop the large losses, because sometimes when the demand is not there, it is not proper to continue the production. Even operate the factories. If there is no demand, it is better to shut down some of the factories. It faced several problems while choosing between the older unit with the cooperative and the productive workforce and abandoning the expensive modern plant where the labor relations are poor. Friends, when we are discussing capacity planning, it is very important to discuss a systematic approach to the capacity decision. Generally, a 4 steps procedure is followed by the manager to make the sound or effective decision. The most common assumption in these procedures is that the management has already performed the preliminary step of determining the existing capacity. That is a very important point. Before going for the 4-step procedure, one has to analyze its existing capacity on a prima or the preliminary basis. These 4 steps are: estimate future capacity requirement, discover gaps by comparing the requirement with the available capacity, build up alternate plan for filling the gaps, and finally evaluate each of the alternative both qualitatively and quantitatively to make a final decision or final choice. If we talk about the first step, that is estimating the future capacity requirement. The basis for estimating the long-term capacity desire, the forecast of demand, productivity, competition, and technological changes that extend well into the future. Unfortunately, larger the time of forecast, the larger is the uncertainty involved in the forecast of demand. That means we are going to get inaccurate or less accurate forecast of the demand. Demand forecast has to be converted to a number that can be compared directly with the capacity measure being used. Now, how you will express the capacity? Let the capacity be expressed as the number of available machine at an operation. When just one product or service is being processed, let M number of machines is required. Here you will find an equation to calculate the number of machine, that is the processing hours required for year's demand divided by hours available from one machine per year after deducting the desired quotient. And we have also given one equation, that is M is equal to dP upon N in bracket 1 minus C upon 100, where D is the number of units, P is the processing time, N is the number of hours, and C is the desired capacity quotient. So this will give you the desired, if you want to calculate or you determine the number of machine required. Now, when we are talking about estimating the future demand and we know the formula, processing time P depends on the process and the method selected to do. The term P is estimated from the established work standard, and that is a very standard terms that how we will calculate the standard time. We take the help of stopwatch, we try to have the ideal person or the efficient person, and then we take with the help of stopwatch we determine the time, and then we exclude some of the allowances and we will get the standard time and then normal time for a particular operation or for particular process. In denominator, N is the total number of hours that are available in the year multiplied by a proportion that account for the desired capacity quotient. C capacity quotient is converted from a percentage to a proportion by dividing it by it with 100. Then we get a proportion. A project or a job does not follow the simple line as we have shown earlier. Its operation may process many different items, and demands on any one operation could vary considerably from one day to the next day. That means on one day one is going for process 5, another day they may process 25. Even we have to identify the bottlenecks by computing the average utilization of each operation. Floating bottlenecks are created by variability in the workload. In 1 month, the mix of work may make operation 1 as bottleneck, and in next week it may make operation 3 as constant or the bottleneck. Here you understand that even the bottleneck may change from one week to another week. This type of variability increases as the complexity of the day-to-day scheduling goes further. Therefore, management prefers lower utilization rate, which will allow a greater slack to absorb the unexpected surge in the demand. Another important point, if we are going for the multiple product or services, then extra time is needed to change over from one product or one services to next. Setup time is derived from the process decision, as is a processing time. The total setup time is established by dividing the number of units estimated per year, that is D, by the number of units made in each lot, which gives the number of setup per year, and then multiplying it by the time per setup. And it is very important because we always miss the setup time, and which consumes a very good amount of time of a process. If I take one example, if our demand is 2200 units and average lot size is 100, then 2200 divided by 100 is the 22 setup per year, and that means we have to give enough time for setup per year, accounting for both processing and setup time. When there are multiple product or services, we have the one relation you will see in the next slide. That will give you the number of machine. Here we have give the due consideration for the setup time, that is processing and setup hours required divided by the hours available. That will give you the mathematical equation where Q is the number of unit in each lot and S is the setup time. Here we are giving you one example about a electronic packaging center operates 250 days per year with one 8-hour shift. The management believes that a capacity cushion of 15% is best. It currently has 3 packaging machines. Determine how many machines are needed at the packaging centers. On the left side, we have given the items. In the middle, we have a client or the about client X, and on the right side column, we have client Y. Then we will see that what is the best capacity step and how you will determine the capacity for client X and for client Y. If I see the calculation, we will give the requirement for 4 machines. If you go by the calculation, it is my personal advice, you try to calculate with the help of calculator and you will find that 3.12, and we have round up to 4 units. Second step is identifying the gaps. There is a difference between the projected demand and the current capacity, and that is known as capacity demand. If we discover the gap and then we require the determination of capacity measure. There may be complication if there are multiple operations and several resources inputs are involved. If I take the example, the bus manufacturing executive incorrectly concluded that the transportation bus having the larger share of seats attract the large share of passenger. Many industry applied this policy, but the competitor with having the smaller buses were more successful. So, in the first point you will see that they have identified the gap, but it was not feasible. The correct measure of capacity was the number of departures than the number of seats. Thus, the several transporters have to make a balance between the capacity of larger and the smaller bus by buying a smaller capacity bus and discontinuing the use of the larger one. Overall capacity might be increased by the expansion of capacity of some of operation. However, if one operation is obstacle, the capacity can be expanded only if the capacity of obstacle operation is expanded. That means we have to give due consideration to the obstacle operation. Third step is developing the alternatives. One of the alternative is the base case in which the firm do not have to do anything and simply lose orders from one demand that exceed the current capacity. Various timings and sizing options for adding new capacity, including the expansion strategy, wait and see strategy, are also present as other alternative. If I take the example of Tata Motors, they have expanded their facility in 2 stages. They have not gone for expansion in one step, they have taken the 2 stages. In first stage, they have added a new production line. In other stage, they have go for the different location and they used short-term options such as overtime, temporary worker and some contracting. Another important alternative or the step is to evaluate the alternatives. And it is the most important point or the step, because you have already identified the several alternatives. Now you have to find the best alternative. In this step, managers has to use his or her skill and to evaluate each alternative both quantitatively and qualitatively. Now we will see how it can be done. Now, what are the qualitative concerns? The manager have to be thoughtful at how each alternative fit the overall capacity strategy and other aspect of the business not covered by the financial study. They are particular concerned about the uncertainty about the demand, competitive reaction, technological change and the cost estimate. And also there are some factors which are judgmental in nature, subjective in nature, and they cannot be quantified. In case of qualitative concern, they have to be assessed on the basis of judgment and experience. Other factors can be quantified and therefore each alternative can be analyzed using the different assumption about the future. One important assumption that represent a worst case where the demand is less but the competition is more. Construction costs are higher than expected. Another type of alternative is what if analysis, which allows the manager to get an idea of each alternative implication before making a final choice. Now we will see the quantitative concern. In case of quantitative concern, we are at some advantageous position because the factors can be quantified. Here the manager approximates the changes in cash flow for each substitute over the forecast time horizon compared to the base case. The difference between the flows of funds in and out of the organization over a certain time interval, including revenues, cost, changes in properties, and legal responsibilities, are called as a cash flow. Here the managers are concerned only with the cash flows attributes to the project. A good example of capacity impact on the revenue is the restaurant in Jamshedpur. The customer liked neon signs that dotted the wall, the high-pitched jukebox, and the way they throw the peanut shell to the floor. However, the customer have to wait for nearly 2 hours to be seated, and the choice on the items was limited. Therefore, this is a very important quantitative concern one has to keep in mind. As a result, the restaurant owner has increased the number of seats. That means enhance the capacity. Also enlarge the size of kitchen to handle the more volumes and offer the more choices. Within 1 month, the restaurant started to bring around rupees 80,000 per week, a 40% increase in the net income. That becomes the prototype for the number of restaurants across the Jamshedpur and across the country. Now, what are the tools for capacity planning? We have either short-term plan, we have medium-term plan, we have a long-term plan. So we have to see what are the different tools which are available for capacity planning. Long-term capacity planning needs demand forecast for an extended period of time. Unfortunately, forecast accuracy declines as the forecasting origin lengthens. Moreover, the action of competitor increases uncertainty in demand of forecast. The demand during any point of time is not evenly distributed. Peaks and valleys of demand may occur within the time period. For these reasons, the capacity cushions are required. 3 tools which are normally used, they deal more efficiently with demand uncertainty and variability. They are defined as waiting line models, simulation, and the decision tree. Let us see one by one the characteristics of each model or the tool. In case of waiting line model, they are generally used in the industry for capacity planning. The waiting line tend to be developed in the front of the work center, such as bank counter, railway reservation counter, machine center, or a central computer. The reason is quite simple, because arrival time of the job or arrival time of the customer varies, and the processing time will also vary from one customer to another customer. So in waiting line model, we consider the arrival time, we consider the processing time. Waiting line models uses the probability distribution to provide the estimates of average customer delay time, average length of waiting time, and utilization of work center. Manager can use this information to choose the most effective capacity balancing customer service and the cost of adding capacity. The waiting line models or the waiting line enhancement provide a fuller treatment of the waiting lines. It introduces formulas for estimation of important characteristics of waiting line, such as average customer waiting time or average facility utilization, or this is required for different facility design. As example, a facility might be designed to have a multiple lines at each operation and to route customer through one multiple operation. Given the estimating capability of these formulas and cost estimate for waiting line and an idle time, the manager can select the cost-effective design and the capacity level that also provide the desired level of customer service. Another tool is the simulation tool. Complex waiting line problem must be analyzed with the simulation. It discovers the blockage or the bottleneck of the process and appropriate customer cushions. Even for complex processes with the random demand pattern with the predictable rushes in demand during a typical day. That means we simulate the situation. We simulate a model and then we can identify the blockage, where our blockage is there, where our bottleneck is there. Another important tool which is very common and very frequently used is the decision tree. As the name indicates, it looks like a tree. It is used particularly for evaluating the different capacity expansion alternative when the demand is uncertain and sequential decisions are involved. If I take example, a owner of restaurant may expand the restaurant now only to discover in 4 years that the demand growth is much higher than forecasted. In that case, the owner need to decide whether to expand further or not. This is first decision. In terms of construction cost and downtime, expanding twice is likely to be much more expensive than building a large facility from the start. However, making a large expansion now when the demand growth is low means poor facility utilization. So there are several decisions you will find in case of decisions tree model. This will give you a brief picture about the decision tree. On the left side, you have a starting point or the seed point for the decision tree, and you will find that there are two alternatives, and with each alternative again there are two alternatives. So when we want to solve this type of problem, we start from the right hand side and we try to solve, and we will come from right hand side to the left hand side, and we will focus the two alternative cost for the restaurant owner, and then we will decide which alternative is costing more, and then we will select the optimum decision. If we see the figure, it is a type of a capacity planning problem solution. The demand can be either low or high with a probability of 0.4 and 0.6 respectively. The initial expansion in year 1 can either be small or large. If you recall the second decision mode, whether to expand at a later date is reached only if the initial expansion is small and the demand turns out to be high. If the demand is high and if initial expansion is small, a decision must be made about a second expansion in year 4. Payoff for each branch of tree are estimated. For example, if initial expansion is large, the financial benefit is either 1,54,000 or 7,68,000 depending on whether the demand is low or high. So we have two alternatives and we are getting the quantitative measure we can find the solution. Weighting or weighing these payoff by probabilities, an expected value of 4 lakhs is coming. This expected payoff is higher than rupees 3 lakhs payoff for a small initial expansion. So the best choice is to make a larger expansion in year 1. Now, how you will manage the capacity across the organization? We have discussed about the tools, we have discussed about the various steps for capacity alternatives. Now we will see how we will manage the capacity. So here the manager make the capacity choice at the organization level. They also must make the capacity decision at the individual process level in accounting, finance, human resource, information technology, marketing and operation, and with other departments also. Capacity issues can cut across the department lines because relieving a bottleneck in one part of organization does not have the desirable effect unless a bottleneck in another part is also addressed. That means one has to be cautious while addressing the bottleneck. Managers everywhere must understand the capacity measure, economies and diseconomies of scale, capacity cushion, timings and sizing strategy, capacity cushion and the trade-off between the customer service and the capacity utilization. They also must understand how such capacity decision link with other decisions that have to be made about their process. After this session, you are now able to explain various types or the various reasons for the capacity planning. There is a very important term which you have learned, that is the capacity cushion. So capacity cushion, time and sizing option and linkages with other decisions are also explained to you, and this type of strategies will help future manager in the optimal decision making abilities. We have also learned various capacity planning tools just like waiting line model, simulation and decision trees. They will further assist to make the good decision. Thank you.